So in this video I am going to talk about types of bioreactors. There are different forms of bioreactors used in bioprocess industry, and some of the bioreactor can be used in wastewater treatment and solid waste treatment, and you might have studied it in your environmental biotechnology classes. And these are the common type of bioreactors used in bioprocess industry: CSPR, airlift fermenter, packed bed reactor, immobilized reactor. So these things will be covered in your seminar, so I am not going to details of these fermenters, but I am going to talk about some other type of fermenters. For example, tower fermenters. As the name implies, tower fermenters are elongated fermenters. They are less diameter with the fermenters with less diameter and more height. So, and another peculiarity of tower fermenters is that they are not mechanically stirred. There won't be any mechanical stirring mechanism in the tower fermenters. The aspect ratio is 10:1, height 10, and diameter will be 1. So, pretty elongated fermenters. And the simplest form of tower fermenters is called bubble column, which is used in citric acid production. And vertical tower fermenters can be used for beer fermentation, and it may have this settling zone downstairs. And there are something called multi-stage tower fermenters. In multi-stage tower fermenters, as it is an elongated fermenter, each portion will have different conditions. Maybe one portion may have an aerobic conditions and another portion may have anaerobic condition. Maybe temperature will be different. So that's what's called multi-stage tower fermenters. So this is how a tower fermenter look like. This very much elongated. So that's why it's called tower fermenters. And plus there is no agitation system, and aeration itself is able to give agitation. This is the aeration point, and when the air goes from bottom to top, it will actually mix the fermenter, and this one is used for alcohol fermentation. Next type of fermenters is called cylindrical-conical vessels. As the name implies, it's cylindro on top of it, and in the bottom you can see a conical portion. This one is the most commonly used fermenters for beer production. Okay, because of its shape, the yeast settling can be done here, and most of these are non-mechanically stirred, and in this stirring is done by carbon dioxide produced by yeast. So cylindro-conical vessels, it has a cylindrical top portion, and the bottom is in a conical form, and the top is basically a semi-spherical. Most common method for brewing is the process of beer production. It is made up of stainless steel, and its top is hemispherical and a conical base. The base is 70 degree. Aspect ratio 3:1. It is not a tower fermenter. Tower fermenter may used to have higher aspect ratio. They are not generally agitated. Carbon dioxide produced by the yeast is actually doing the agitation, and most of them used to have cooling jackets to reduce the temperature of the fermenter during the fermentation. Then we have airlift fermenters. Airlift fermenters, you might have heard about the airlift fermenters in environmental biotechnology classes. So this is actually the main fermenter region. Here what we do, here we are introducing air. So here we have this parcher. Through this parcher we are introducing air, and this what the air is doing is like air will reduce the density of the medium, and as the more air is introduced into the medium, what happens, the medium will go up, and when it reaches here, what happens is like the air will be released into the outside, and the density will become higher, and so it will flow in this direction. Here we have a heat exchanger to control the temperature. Then it will go like this, and again it comes to the first parcher. So in airlift fermenter, the medium is lifted to the top by using air. So there will be a continuous circulation of air in a airlift fermenter, and it is an external flow airlift fermenter. So we have a loop here, so it's called external flow. We also have internal flow airlift fermenter, which looks something like this. We are providing air here, medium is going up or going up. Here the gas is released into the environment. So once it is released, it will go like this and again reach here. So there will be a continuous circulation in the internal loop. Deep jet fermenters, it is used to get higher aeration, and it mainly used in continuous cultures. it is circulated liquid medium using mechanical power. Okay, and we have two different types of deep jet fermentation setup. One is gas injector and a liquid injector and liquid ejector. Here the medium from the fermenter is withdrawn and passed into this system. In this system, what happens? The medium is passing here, and on the way we are adding air into it. So air and medium in high pressure is released into this tube. So once it is released, what happens? The air will be the air bubbles will be integrated into the medium. So there will be high level of aeration. In liquid ejectors, the medium only is passed into this tube with a high pressure. As the diameter decreases, there will be increase in pressure, and it is released into a larger pipe. At the same time, this whole place is filled with air, maybe air with a more percentage of oxygen. So during the time of passing from this low pressure region to high pressure regions to low pressure region, the liquid will expand. At the same time, air will be integrated into the medium, and this whole setup is used to increase aeration efficiency. Cyclone columns. Cyclone column is another type of bioreactor. It is used for the growth of filamentous cultures. The thing is that in filamentous cultures we can not really agitate the system. If you are using an imbalance, the filamentous growth will be broken and the death will occur to the mycelia. So in order to avoid that, we can actually use cyclone column. It has a good gas exchange capacity, and the chance of forming is less, and the wall growth possibility is also less. And it will look like this. This is our fermenter. From the fermenter, we will withdraw the medium, and this is how we draw a motor, and it will pass it into the top of the fermenter. And fermenter is like an elongated vessel. And here, what happens? The medium will take a cyclonic motion. So it goes like this through the walls. Through the walls of the fermenter, it goes like in a cyclone-like movement. So during that time of movement, it will get enough space for the aeration. So the aeration is done during this cyclonic movement, and which is good for the filamentous growth because there is no mechanical agitations and no chance of breaking down of the filament. Packed tower reactor. It is also used in environmental biotechnology applications as packed bed reactor. Basically what it has is it has a region with some inert materials like wood shavings, sand or something like that, and microorganisms will be growing on top of that, and our medium will be sprayed over here, and once it is trickling down, the microorganism will convert these components into products, and it is used for acetic acid production, and it is environmental biotechnology applications also it is used, and is used for vinegar production, of course. This one RBC, rotating biological conductors. It can be also used for biofermentation applications. Here we have a rotating disc, and on top of it the microorganism is growing, and so the disc will be rotating in speed of 1 rpm or so, so that during the time when the disc is exposed to air, there is a good chance of aeration, chance of getting good aeration. So those are the type of fermenters commonly used in bioprocess technology. Thank you so much.